Okay, so welcome to class. Today we're covering creating functions, user-defined functions and your own functions. They're really similar to each other. Let's take a look at them. Oh, I closed Excel. I didn't mean to close Excel. What was I thinking? I had Excel open. What are we going to do? So we'll open up Excel, blank workbook. And what I'd like to do, a little thought experiment. I want you to pretend that you can imagine what the 1970s were like. I mean, how many of you, is anyone here alive during the 1970s? I was, but I was like 2. No one alive. Imagine what it was like. Bell bottoms, disco. It was a fabulous time.
Horse and buggy.
There's no horse. Well, probably some horse and buggies, but it wasn't the main mode of transportation. The main mode of transportation was the Gremlin. That was a car. You guys know what the Gremlin is? Yeah. Fabulous car.
That's where the Russian go.
Only improved upon by the Pacer. Look at the Gremlin and the Pacer sometime. You'll see what driving in the 70s was like. But let's take a look at. Oh no! So imagine for a moment that you are like an executive at a credit union, not a home savings and loan. In the 70s, it was okay to be in the home savings and loan business. In the 80s, kind of a bad idea. But let's suppose that you're going, you know what? I think these computers are the future. You decide, I think it's time to get our records on computer here at the bank or the savings and loan, whatever it is. Here's a problem. We don't have very much processing power in the 1970s. We don't have a lot of disk space, and telecommunications is extremely expensive. And so this idea of saying, well, we're going to communicate with another server somewhere else to get some information and pull it over, we're going to do that when we're not going to do that very often. So now let's suppose, with me, a little thought experiment. Let's suppose you're going to create the screen that allows you to make a deposit. A teller is going to work this thing. Someone's going to walk up to the teller, the teller's got a computer, and they're going to make a deposit. What's the screen going to look like? What information do you need to be able to make a deposit? Okay, so we're going to need to know the account number. Let me put that in here. We got account number. We only got 80 characters across the screen, so we've got to abbreviate. Everything's abbreviated. Account number. And there won't really be a way for us to put a block on the screen because it's only just characters. I'm going to pretend we could put some indication that that's where the account number goes. Okay, great. What else do we need? What's that? The date? We don't need the date. That's the great thing about these computers, is that they know the date already. We don't have to enter the date.
The amount.
We do need the amount. We've got account, and we've got amount. And we might want something else, but let's pretend we don't. Okay. So, given an account number and an amount, we can record this deposit. They're going to give us some money, and that's the whole point. We got to record where that money is allocated so that sometime later when they withdraw it, we can go, oh yeah, because you know what? We don't have a little bin back there for their money that we put in. It's sitting there. We put it in a big pile, and then we lend it out. But we got to keep track of it. That's the whole point. Okay, so now talk to me about the risk. What's wrong? What could possibly, this is a great form, what could possibly go wrong? Yeah, probably the biggest thing, you're going to enter the wrong account number. Now, so let's think about how we're going to solve it. How are we going to reduce that risk? Am I recording? Yeah. How are we going to reduce that risk? We want to do something that we have some way to validate that that account number is the one we meant. Go ahead.
Put it in twice.
Okay, so what is one option? Print it, you type it in twice. And that would be okay if the error happens at the fingers on output. But if the error happens on input, I'll read it wrong, I'll type exactly the same thing. So that would help. And the thing I like about that solution, it doesn't cost any processing because processing is expensive. I don't have to do some kind of lookup across the network somewhere. So there's some points to that. Go ahead.
You have a database that has the account numbers lined up with the name, and as soon as you type in the account number, the name pops up.
Oh, you're thinking like the 1980s. Yeah, so validation person's coming in here, we're going to say, okay, Mr. Smith, thank you for coming. Oh, you're not Mr. Smith? Wait, made a mistake. We got to fix this problem. So yeah, the reason that's not satisfactory is because the delay that it takes to get that information back is too long. Telecommunications is not only expensive, it's slow. And so, not happening. Okay? Other thoughts?
Input controls.
What's that?
Input controls.
Input controls.
Data validation. You can only put in certain sorts of.
Okay, so maybe you're going to say, hey, all of our check digits, all of our, what are they called? Account numbers are 9 digits long. Make sure it's only 9 digits. That's a pretty inexpensive thing to do. So if we accidentally typed an extra character, or not enough characters, we'll click that. So, okay, so I like it. That's not what I'm after. Well, there's one more thought about this.
Secret password.
What's that?
Secret
A secret password. So how does that happen? The teller asks the person for their secret password? Yeah. What's your secret password? Yeah, that's probably not going to work. But thanks for giving me the last one so that we can move on to one-on-one talk. Okay, I'll tell you about the solution. Here's the solution that we came up with in the 1970s. And it was pretty quickly improved upon. Let's suppose that I've got my account number 1, 2, 3, 4, 5. That's the account number. And maybe all my account numbers are 5 digits long. And of course, there's going to be a routing number and whatever for the full account number. I'm just talking about the identifier of this particular account. Here's what we would do, is we would say, you know what? Instead of just making the account number those 5 digits, let's make it 7 digits. Let's put on a couple more digits on the end. But let's make sure that those digits are the sum of these other digits. So now, by looking at this, we can say, okay, we're now typing in 7 digits instead of 5. But now, with very little processing power, we can split this into 2 sets. We can look at these two here, and we can say, okay, set those aside. I'll sum up these other digits and check to see if whatever we summed up equals these last 2 digits. So these two, this 2 at the end, this 15 at the end, doesn't have anything to do with identifying the account. It's just the results of an algorithm that help us know, did you type the account number correctly? This is called a checksum. And it was something that pretty quickly we said, you know what? If we type the wrong number in and it's a valid account, that's a real problem. So now, if a person makes an error typing the first 5 characters, they have to make the exact compensating error in the last 2 characters to be able to have that come back and say, yeah, this is a valid account number. Pretty smart. What's the biggest problem with this approach? What's the most common typographical error? A transposition. And so if I change the position of the 1 and the 2, does this? It still works. Yeah, this still works. And so checksum was our first step. And then pretty soon some smart people said, you know, if we had a little bit more, math is easy. For computers, math is easy. If we had, or at least arithmetic, if we had a more complicated algorithm, then maybe we could even come up with an algorithm that protects against the transposition of numbers too. And then the gold standard is, if we could do that, if we could say, here's a number, we want to know if any one number is wrong, or if any 2 sequential numbers is transposed, and it only takes 1 character on the end for us to be able to accomplish all that, so there's less typing involved. That's great. And so, and that's typically what happens. So today, anytime we've got an identifier that has to be typed in repeatedly, there is always at least one, and almost always just 1 digit that's added onto it that is just called a check digit. The algorithm that we use to calculate that could be fairly complex. We're going to take a look at an example of that today. But while we're here on depositing in the 1970s, who can tell me who Frank Abagnale Jr. is? Yeah, go ahead.
He was one of the greatest con artists of his day.
Oh, he's a con man. He's in the 1970s, late 70s, early 80s. So his very first, in fact, he's the subject of a book, Catch Me If You Can. He claims that he even conned his way into a faculty position at BYU. The university denies them. They say they have no record. I'm not sure who to believe on that one, but what's that?
Good con artists with blue tracks.
Yeah, I don't know. Yeah, so who knows? If I really had to guess, I think he probably did. His very first financial instruments fraud, I don't have time to talk about his very first fraud. This is interesting. But his very first financial instruments fraud was this very thing. He noticed at his local bank that there, right at the little counter when you walk in, you can get yourself all organized before you get in line, and there was a stack of deposit slips right there. I think they still have them. So one deposit slip, you put your account number in. The ones that come in your checkbook, they already have your account number on. This one, put your account number in, and then You can put your name and everything. List out your deposit, make your deposit. Well, he noticed that a fair number of the bank users that came in to make a deposit, they had no idea what their account number was, and so they would just write in their name, leave the account number blank, and then they would do a lookup to find out what was the account number. And they would deposit. But if the account number was written in, the teller would just look at the account number, key it in, make the deposit, and move on. So he went to the bank, and he took a stack of those counter deposit slips back to his home. With a typewriter, he typed in his account number on all of them. Took them back to the bank and put them on the counter. So now Edna comes in to deposit her Social Security check. She takes out just like she's always done, she takes out the counter slip, she writes her name on it, endorses the check, takes it to the counter, deposits it into his account. A week later, he closes the account and walks away with, I don't know, that's his very first financial instruments fraud. His big contribution to banking fraud was to actually print checks with bad routing numbers on them. These routing numbers are automatically, the machines look at these checks and they send them off to different places. So there's a check that's supposed to clear against the West Coast bank, and the checks are getting routed to the East Coast by the routing numbers. It would take almost 3 weeks for these checks to clear. So you can come into town, you can write checks for 3 weeks, and no bank would ever know they were bouncing. And that's the only signal that the bank has that it's a bad check, is that it's going to bounce. And so he figured out how to delay the time for it to bounce by a pretty substantial rate. But enough about Frank Abagnale Jr. It was a good book. But where were we? Okay. So we're going to look at check digits. So if you have a book, if you have a print book with you, take it out. And you've got a number on the back. It's called an ISBN, International Standard Book Number. The last character in that ISBN is the check digit. If the book's relatively new, printed within the last 6 or 7 years, chances are it has a 13-digit ISBN. Probably starts with 978. You have a 13-digit, start with 978. So when they went from 10-digit ISBNs to 13-digit ISBNs, it used to be ISBNs just for books. But now a 13-digit ISBN is actually an EAN, which is it's a general product identification code. And the first three digits just say book. This is the book, first 3 digits, and then it's the identifier for the book. And the last digit is the check digit. And there's a fairly complex algorithm that we use to look at that check digit and see and validate the rest of the numbers. And so that's our goal today in class, is to be able to write a procedure, a function procedure, we'll talk about that, in VBA, so that right here in a cell we could say, you know what, here's an ISBN. In fact, I'll put in this one. This ISBN is 0-13-167272-X. X is kind of a perplexing check digit, but that's what it is. So the idea is that we could write a formula, use a function right here that looks at this check digit or looks at this ISBN and just tells us it's a valid ISBN or it's invalid. In other words, it looks at the number, applies the algorithm, and checks to see if it has the right check digit. If it does, it'll say it's a well-formed ISBN. We don't know if it's for a valid book, but at least we'll know that it's a well-formed ISBN. That's where we're headed. Are you ready?
Yes.
Let's do it. Alt F11. Bring up our code window. What have I done? Book 1, this worksheet. All right, I'm on book 1. I am going to insert a module. Book 1, we've got a brand new module. Okay. I'm going to build a function that we're going to use, but this is going to get us going with the idea of what a function procedure is. So far, every time we've written a block of code that we wanted to store in the workbook, we've made a sub-procedure. Sub-procedure is a bunch of statements. We say, run this, it's a set of statements. Run this set of statements, and it goes bing, 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 runs through them all. And when it might be a loop, goes up and does something several times. Once it's done, it's just done. And it's over. You wanted me to do it, I did it. Function procedure, just like a sub-procedure, except when it's done, it sends a value back to where it was called from, which is why over here on the worksheet, we'll be able to use this function to see the result of the function when we pass it this. We would tell it operate on this ISBN, and it will tell us the answer right here because the function sends the value back to where it was called from. We call it from the cell, the value comes back into the cell. We call it from the immediate window, the value will come back to the immediate window. We call it from another procedure, the value comes back to just wherever it was called from, it sends the value back. So here's how it works. Instead of starting off by saying sub, we start off by saying function. We then give it a name. So I'm going to start with one that we're going to use in the process of validating the ISBN. So we're going to start with one called numbers only. So the idea here is I would like to be able to send it some string. I'd like this function to look across that whole string and say, you know what, there's some letters, here's a period, here's a hyphen, forget those. There's a number. That's going to go into what's coming back. Here's the next one's a number, then a number. Oh, then some letters, skip those, another number, bring that down. Skips it, here's another number, bring it down. I want to be able to look across the string and just take out the numeric characters and send back the numeric characters. If it's a non-numeric character, I don't care. Pretty simple function. Are you ready to write it?
I have a question. So would that have worked last week or last class with the phone example where we just wanted the digits? We could have just said numbers only.
That's right. That very thing. In fact, that would be a good use for this if we're saying, listen, we've got these kind of formatted numbers, telephone numbers, there's parentheses, there's hyphens, there's spaces. I just want the numbers. Pass it the whole phone number, parentheses and everything, and it would come back just the digits. Yeah, it's exactly what we could use. That would be a good use of the function we're about to write. Thank you for pointing that out. It now seems even more relevant than it did moments ago when I thought of it. Numbers only. I'm going to have to pass it something to work on. So, we haven't done this before. I'm going to pause on that for a minute. So this is how we would normally do it. We would say sub, give it a name. Function, give it a name. Now, what's different? A function is going to return a value. We have to say what type of value is it going to return. Just like we create a variable, we say dim x as integer. When we create a function, we have to tell what type it's going to return. So in this case, I'm going to return as a string. Now, I'm going to send it something. We'll see how we send it something here in just a minute. But it's going to return back a string. Why a string instead of a number? Some kind of number. It's not because of the x. So this is just going to return numbers. The reason I want to have this return a string is because I don't want to chop off a leading zero. If someone sends me a collection of characters and the first one happens to be 0, as this ISBN is, then I want that 0 to be preserved. And as soon as I put that into a number, the 0, any leading zeros are going to be gone. We won't know about it. But if they're strings, that'll be okay. So we're going to have it return as a string. Okay, so step 1 is set up the function just like a sub procedure, but I use the keyword function instead of sub. Second thing now that's different is we have to specify a return type. Third thing that's different is I have to do something to tell this function what to return. Most programming languages that allow functions, and that's most of them, there's a statement, and it's almost always just return. The statement is return. Return something, and that's what the function returns. VBA doesn't do that. VBA is really weird in this context. It says the way you set the return value of the function is by setting the name of the function equal to the value you want to return. There's some logic to that. Ultimately, this function is going to have a memory address that it's going to store the value that's getting sent back. And just in the same way that you would put a value into that location in memory with a variable, name of the variable equals something, we're doing the same thing here. Name of the function equals something. Internally, it's doing the same thing. That's why the language came this way. Although, from the outside, it seems like a really different thing to do. So that's what we do. So I'll do that. Numbers only. I'm just going to come here at the very end. Name of the function equals Nephi, some string. So now, I can call this function from the immediate window. I want to say print the results of this function. Seems weird because it's not actually going to be numbered. Nephi would never come back, but it's a string. It could send this back. And so it says, yeah, there it is. When I said print this, it said, well, to know what this thing, what this expression evaluates to, I can put the parentheses on the end so you'd like to see that. I can before it can know what this evaluates to, it has to go and actually execute it. So it goes and executes this code, whatever it does, it ends up with some value here. And then it says, okay, you want to print what this equals? That equals Nephi, it prints it out. Could do the same thing from my worksheet. I could say this equals numbers only. Numbers only. And that value comes right back here. Wherever it was called from, that's where the result goes back. We're okay with this part?
Why are you calling it Nephi if you want to return those like ISBN numbers?
Ah! So at this point, the question is, why are you calling it Nephi? Shouldn't this be some string of numbers? Yeah, it should be some string of numbers. I'm just showing you that whatever we set it to, that's what's going to be returned. So now I'm setting it to 1, 2, 3, 4, 5, 6. That's what's going to come back. It's going to take a little more work to actually figure out how to parse that string out and just get the numbers, but that's where we're at. Okay. Yes?
Does it store it in the workbook or in Excel?
Oh, so the question is, where is this function saved? And the answer is, it is saved in this module. So wherever this module is, it's always saved in a workbook.
So we'd have to repeat that if we wanted to apply to the string.
So the question is, we have to repeat that if we want to apply to different workbooks. And the answer is no, because I can refer to this function from any, as long as it's open. Any other workbook can refer to this as long as it's open. So if you wanted to have something that was always open on your machine, you would just put this function in your personal macro workbook, and then it would just be available all the time. Okay. Now this next part is going to look different because we've never done it in a sub-procedure, but this part you can do in a sub-procedure exactly the same. It happens that the function procedure is where it makes sense because here we got to send it a value. Our job here is going to be to implement some kind of algorithm that will operate on any string. You tell me the string, or you give the function the string gives you back just the numbers from the string. So we've got to give it a way for it to know which string to work on. Now let's think about this. You've got some experience in Excel. And so if you were saying you had some function here and you wanted to send it a value to work on, how would you tell it? What would you tell it what it should work on? Looking here, where would you put it? Yeah, inside the parentheses, you would put something here that says, I want you to work on 1, 2, 3, AB, ASDF, 1, 2, 3, 4. That's what we want you to work on. So we have to set up that function so that it can receive that value that's being sent. We haven't done it yet, so do that. And that's exactly what these parentheses are for. These parentheses right here, we've seen them since the very beginning, since the very first day of the semester. Did we do it on the very first day? Anyway, pretty early in the semester. We've seen those parentheses. And finally, I know you've been wondering, what are those parentheses? Something. This is what it's for. It allows us to declare a variable right here inside the parentheses. To declare a variable that will receive a value when the function is called, or the subprocedure is called. Works for subprocedure or function procedure. Right here. Dim data as string. I'm declaring a variable right here. As it turns out, the only thing I can do inside these parentheses is declare a variable. That's the only thing that's allowed. I can declare more than one, comma, another one, comma, another one. And because that's the only thing allowed, I don't have to put the keyword dim right here. In fact, I can't put the keyword dim. But it's exactly the same. I'm making a variable right here. It's a special variable called a parameter. And now, for this function to be valid, a call to this function to be valid, it has to supply a value here. And so if I try to execute this line, it's going to say, hey, you got to give me that's not optional. It's not optional. Argument, not optional. You've got to put a value here. So now I can put something in here, hello, and then it will, so here's how it works. It's going to take these characters, hello, and it's going to assign them automatically, when I make this call, it will assign them to this variable. So now if I run this, it'll do the same thing. It'll print 1, 2, 3, 4, 5, 6. But now watch this. I could print hello, I could print data, concatenated with a space, concatenated with data. Print twice. It's like that. It's like the duplicator. Whatever you put in, it puts back 2. Because when I call the function, this value is assigned to this variable. And then anything I do with that variable in this code is going to have, it'll have whatever value was in it when the function was called. You see how this works? Typically, when we want to give a value to a variable, we say name of the variable equals its value. Here, it's a special case. When I'm calling a function, I can say, oh, you know what, there's a variable expecting a value here. The way I give that variable its value is by putting it in the parentheses right when I call the function. So now if I went and did that over here in my workbook, hello, we print hello, hello. Just whatever that's operating on the value that it's put, that we send to it, whatever it does with that, goes back to where it was called. This is a little bit of a step. Folks, how are we doing? The key is to just think of this as like the doorway that the value comes in to the procedure. Go ahead.
So, okay. So numbers only, we're trying to return numbers.
Yeah.
But we're like assigning, but we're assigning numbers, we have to assign numbers only something. So like, that doesn't make sense that we're running a function numbers only when we have to give numbers only like a variable.
Okay, so here's
So,
the idea.
Like we're telling numbers only what to do, and we're asking it to return numbers only.
So let me show you what I want to have happen. What I want to have happen here is I want to pass it something like this. Hello, really, I guess. Hello, 1, 2, 3. Goodbye. If I passed it this, I want it to return to me 1, 2, 3. So I'm passing it a string, and I want it to send me back just the numbers from that string,
Right.
in the same order that they exist in the string.
Right. Yes, I
Okay, so that's the goal here.
Right.
So now tell me your question.
But aren't we just, but it just, okay.
I think maybe, are you asking?
But we just returned hello, hello, right? So I'm confused.
At this point, all I'm doing is demonstrating that the value that comes in here can affect what this function returns.
Okay. So because it hello enters hello, because there's no numbers in hello, so I'm just confused why it returned.
We have a whole lot of algorithms to write in here that will actually do the work that I'm talking about here. We haven't written that yet.
Okay.
At this point, we're just getting the basics down here that says this is the approach of how you make this thing return a value that's dependent on what was passed in.
Okay.
We've still got to write the algorithm that does that. Let's do that now. To do that, we're going to take a look at another kind of loop we have not yet seen before. So it looks like you got some clarity from the student next to you.
Yeah. I thought that was like a command. It's just you're just like you just made up the numbers only. Now we have to write the code that does it.
Ah, yes, yes, yes. The name here is arbitrary. We're making up this name. We are creating a new function. And we're defining it right here. That's exactly what we're doing. Thank you. All right. New kind of loop. So far, the only loop we've talked about in class is called the do loop, right? You start with do, you end with loop, and it loops. You get it some way out. Here's another one. It's called the for loop. For us to have a for loop, we have to have a numeric variable that's going to be a part of how we control this loop. I'm going to declare a variable called x as an integer. Dim x as integer, and now the for loop comes here. Here's the syntax. For x equals some start to some end. For x equals 1 to 10. And then next. Now everything inside this loop is going to execute 10 times. I'm going to change numbers only to return nothing for now, a zero-length string, so we won't see it. But I'm going to I want to be able to see what this function, what this loop is doing, so I'll put a debug.print in here, just so I can look at it. I want to print hi there. So if we think about what's happening here, we're going to call this function. It's going to hit this loop. This is going to execute 10 times. It should print hi there 10 times. Oops. What's that?
Does it automatically increment the x then when you make
Let's get to that in just a minute. Okay, so I'm calling numbers only. I'm passing it a zero-length string because I'm not doing anything with the string just now. I've set it to return a zero-length string, so we're not going to see what it returns. The only thing we should see it do is to print this. What I'm counting on is that's going to print that 10 times. It's tough to count, but I think if you count them, pause the video we're making, actually count them. They're really there 10 times. But yeah, so now the question is, so what's this x business for? And the answer is that x, the magical part of this loop, is that the x is going to automatically change its value as this loop executes. So the first time through this loop, x will be 1. When we hit the keyword next, it's going to add 1 onto it. And the next time through the loop, x will be 2. So now if I execute this, it should print hi there 10 times, and it's printing the value of x. The value of x is changing. So this is fabulous, because now we've got a loop. So often we have to say, you know what? I've got to iterate across this, and I want this value to change by 1 each time. A loop that's so common they built a loop for it. It's the for loop. Here's another thing about the for loop. I can tell it to count by more than 1. Step 2. So now it's going to start at 1. It is going to print whatever is there the first time. Now when it hits the keyword next, it's going to add 2 to x. So now the loop's not going to iterate 10 times. It's going to iterate 5 times. X is 1, then it's 3, then it's 5, then it's 7, then it's 9. Here's the thing that I want to point out about this. Put a debug.print after the loop. X is now equal to, and I'll put x right here. This is a little bit odd, what's about to happen. 11, how did x, I never told it to go to 11, I told x to go from 1 to 10. How did it get to 11? The answer is, the way this loop ends is not that x got to 10, it's that x got bigger than 10. This loop ends when x goes outside the boundaries that are set up right here. And so x started at 1, it stayed in the loop, it printed that. It printed that first one up there. Got to the next, that added 2 to it, x is now 3, it printed 3. It added 2, it printed 5. It added 2, it printed 7. It added 2, it printed 9. It's still inside its boundaries. It added 2, it's now 11. It said, oh, we're outside the boundaries. And we get out. So that's a little bit of a weird thing that x actually goes, in fact, it will always go outside of that boundary once it's out of that loop, because that's how it gets out of the loop. X goes out of bounds. And then it says, we're done. Questions? Okay. So now here's what I want to do. Next step, instead of printing x, hi there, I would like to print x. And then I would like to print the first character that I passed in. So if this is 1, 2, 3, A, B, C, 1, 2, 3, what I would like this to print is I would like this to print 1, and then, actually, let's get rid of the x. I don't want to see the x. Oops. I want it to print 1, then 2, then 3, then A, then B, then C, then 1, then 2, then 3. So now, as I'm looking at the control of this loop, I'll leave the step in there, but I'll set it back to 1. That's the default. If I don't include the step 1, it will add 1 to it. Okay, now there's something a little more complex here. Now, I don't know how many characters, how many times this loop is going to loop right now, because it has to change based on what's sent in. So, what am I going to do? How could I look at what got sent in the data variable and figure out how many times it should loop? We talked about this in class len. Yeah, the length. And so, right here, instead of saying to 10, we're going to go to the length of data. Listen, that'll tell me how many characters there are in this string that was passed in. And now, that'll iterate the right number of times. Now I need an expression that will print the right character. I want to print 1 first, then 2, then 3. Let me write it first without worrying about the variable. Mid, look at data, start at the first character, take 1 character. That'll print the first one. I'm going to think through these steps without thinking about a variable. The second time it prints, I want it to print the second variable, or the second character. Start the second character, take 1. Then take the third character, take 1. Start the fourth character, take 1. Start the fifth character. This is what I want it to do. So now as I look at that set of statements, how can I pull that back down to just one statement inside the loop, and what change would I have to make so that each time first time this executes, it would print, it would do this, second time it does this one, third time it does this one. Do you see what I'm saying? What change do I have to make to this one so I can get rid of the rest of these and it will just do it? Change that first one to x. Now the first time through this loop, x will be 1. It'll say start the first character, take 1. Second time through the loop, it says start the second character, take 1. Third time through the loop, start the third character and take 1. We see it? So now if I run this, I should get those characters I've now kind of cut this thing apart where I can look at these one character at a time. All right, so now I've isolated that character down to just 1, and I'm ready to kind of look at it and say, hey, is this thing a number or is it not a number? Here's how we do that. I'm going to do these next couple of steps together. I'm going to declare a variable called temp. It's going to hold the string that I'm building. So it'll be a string. And I'm going to declare a variable called one_char as a string. Now, this temp is going to be a different size depending on how many numbers are passed in. So this should be a normal string. But one character, I'm going to make it hold just exactly one character. And so rather than using a variable length string, which is what this is, I'm going to make it a fixed length string by specifying the number of characters in the string right here. Normally, a string variable has how many bytes of overhead? 4 bytes of overhead. The first 4 bytes just say how long the string is. So if I look in memory, the first 4 bytes say how long the string is. After that is the string that I'm reading. With a fixed length string, I don't have to tell it how many bytes there are because I've specified that here in the code. I don't have to store that in memory. It's right here. And so it's just a little more efficient. I've just saved 4 bytes of RAM. Okay, so now instead of printing that character, I'm going to put that into one character. One_char equals. And now I'm going to look at it. I'm going to say if there's a function called that will actually tell me, look at the string and tell me if it's a number. It's called isNumeric. It's part of the VBA language. I can give it a string, 1, 2, 3, and it will tell me if it's numeric. True, that's a number. If I put a letter in there, it tells me that's not a number. So isNumeric looks at a string and tells me, could I convert that into a number? So I'm going to use that to determine if the character I'm currently looking at should go into the output set. So I'll say if isNumeric. I'm going to look at one_char. That will be true or false. What I have between the if and the then has to be true or false. So if that evaluates to true, then we're going to do something. What are we going to do? We're going to say temp equals what it used to be, and we're going to concatenate on one_char. Every variable has a default value. When I create it based on the type, it's going to have a default value. When I create x, it's got a value. What's the default value for x, for an integer type? It's going to be 0. What's the default value for a string? Empty string. So temp is going to start off as an empty string. So the first time I hit this, temp is going to be what it used to be, an empty string, plus whatever character I just found as a number. Next time I get into this if statement, temp is going to equal what it used to be, whatever that character is, plus whatever the new one_char is. Now the only thing I have to do, so that's going to build up a string of just the numbers here in this variable temp. All I have to do now is say that's what I'm sending back. The numbers only is going to equal temp, the result of what I was working with. So now I should be able to execute that and it will bring back just the numeric characters. If I send a telephone number, that should give me back just the numbers from that string. And we can do this in a worksheet. So if we've got these characters now sitting over here in our worksheet, we should be able to say equals numbers only, Tell it to look at that cell, and it will evaluate just to the numbers. Whew. That's the algorithm. How are we doing, folks? How many were looking at this going, oh, it's witchcraft? Okay, so if you're feeling that way, good news. We have TAs. Cameron? And do you have a TA here? You have a TA. Undercover TA?
Don't need another one.
Cameron is all we need. Come see me. We got the video. I don't know if review the video is going to help anymore. We're going to see a couple more shots at this. Or at least one more today. But this is the whole idea for a function. We're going to implement some kind of algorithm. Almost always we send it something to work on. We work on it, and then we send back the result. Okay. Now that we've been through the kind of the first example of dealing with a function, it's time to do the one that we're really after, which is to see if we've got a valid ISBN. Go ahead.
Are all functions going to end with temp?
Will all functions end with temp? And the answer is no. This is just the way that I was trying to figure out what I wanted to return. All functions should, at some point in them, say what it's going to return.
So what does temp mean?
Temp is just a string that we created here. It's a variable named arbitrary. Could have called it anything. It means temporary variable. It's a holding place until I can send the value back. Might have been a better name. I couldn't think. Okay. So now let's look at another function. Function, I'm going to call it is valid ISBN 10. So is this a valid 10-digit ISBN? So folks, the old way of doing ISBNs are 10 digits. The new way is 13 digits. I'm going to show you how to write the algorithm for a 10-digit to validate a 10-digit ISBN. In your next project, you are going to write an algorithm to validate a 13-digit ISBN. So what we're covering here today will really be helpful for that next project. Like some of you came to me. I'm having a hard time working on this next project. Oh, don't do that until we start class today, because I'm going to show you how to do it. Okay, so here's the idea. We're going to send it some candidate ISBN. Someone says this is an ISBN. And we've got to say it's valid or it's invalid. So I'm going to say I want to accept into here a candidate. So this is going to be a parameter. I'm declaring a variable here as a string. This is a function, so it's going to return a value. I got to say the type. What type is it going to return? Let's think about it. You're going to send me, I'm the function over here. You're going to send me some string, and I'm going to tell you what? It's either valid or invalid. I could do that with a string and send back valid or invalid. But what's the more standard way to do it?
True or false?
Just send back true or false. And so if I do that, what's the type? That's Boolean. So now this function can only return true or false. No matter what else I do, it can only return true or false. Now we got to look at this thing and figure out what we're going to do. Well, here's the first step. Let's imagine a string. Here's the idea. If I look at this ISBN here, it's got dashes. 13 dash 6. No, 0 dash 13 dash 16. It's got dashes in it. I think I'm okay with that. I think if someone types in dashes or dots or spaces, great. In fact, that's why we wrote this numbers only function. I want to send down whatever they gave me, and I want to say, just give me back the numbers from that. And so, even before we think about even looking at the details of what they sent, can you imagine what might be an invalid ISBN? You could just look at it and quickly say, that couldn't possibly be a valid 10-digit ISBN. It's got to have at least 10 digits. Could it have more than 10 digits? Yeah, if it had hyphens and spaces and dots, that'd be okay. But if it has less than 10 digits, we're not going to make up any numbers. If it's got less than 10 digits, it can't be valid. So let's just handle that right off the bat. We'll do a check. As soon as you get here, listen. If you've got less than 10 digits, false. I don't even have to look at it. So here's how we would do that. I'm going to come right here with an if statement. If the length of the candidate is less than 10, this can't possibly be valid. Then, exit function. Now, this exit function, the whole idea, I'm going to have a bunch more stuff right down in here. But if the length is less than 10, I don't even have to look at it. Now, have I told it what to return? How do I tell this function what to return? Somewhere I got to say is valid ISBN equals. Every data type has a default value. For strings, it's a zero-length string. For any numeric type, it's 0. For Boolean, it's false. If I never tell it to return true, it will return false. It will return its default value. And so since this would be false, I don't have to tell it anything. It will return false. Get me out of here. By the way, return false. All right, so what do I know if I make it to this point right here? And if I get to this point in my code, if I make it to here, what do I know? I got 10 or more digits to work with. Okay. So now we'll do some other checks. And if it fails any of these other checks, get me out of here. Ultimately, we'll get down to the very end, and if it hasn't failed any of those, return true. Let's take a look at the algorithm. Let's see, ISBN Wikipedia. International Standard Book Number. Oh, that's the International Standard Book Number. Overview, India, Italy, whatever. Aha! ISBN 10 check digits. Here's the algorithm. I think there's one. Yeah, it's written for calculation a little bit easier here. Doesn't quite all fit on the screen at this resolution. We're okay. I'll cover you on this part that's missing here. Okay, so first of all, how many of you are looking at this and going, oh my gosh? It's actually not too bad. Let me show you what this is doing. What we're seeing here is that this first line is the whole algorithm, and then they're just collapsing part of it and showing it this, and they're collapsing it again and collapsing it again. So it's really only this first line. So here's what it says. It says take 11, and then subtract this long thing here. Here's what this is. Here's the ISBN that we're working with right here. We're trying to figure out what the check digit is for this. With these first 9 characters, what's the check digit? So here's the algorithm. It says take this 0, that's this 0 right here. Take the first character, multiply it by 10. Add that to the next character, multiplied by 9. Add that to the next character, multiplied by 8. Next character, multiplied by 7. Next character, multiplied by 6. See how it goes? Just take all these characters, multiply the first one by 10, and then go down as you go through the numbers, count down. Once you've got that, it's 11, here's this. You're going to take that mod 11. 11 minus this mod 11. The remainder of this one divided by 11. And then you're going to take that whole thing, mod 11. And that's the check digit. Let's do it in VBA. Can you feel the loop? Can you feel the loop come in on this? Here's the first thing I want to do. What you're going to notice, what we're looking at here, is we are looking at the first 9 digits calculating the check digit. So I want to start off by splitting this into 2 parts. First 9 characters and the check digit. And then we'll work from there. So I'm going to declare those 2 variables, dim check digit, as string, only 1 character long, star 1. It's going to be fixed length string, that's fine. And then I want to dim, I'll call it first 9. As a regular old string. All right, so we have declared a couple of variables. We've checked to make sure we've got at least 10 characters. And now I'm going to split that candidate into those 2 parts. So someone give me the VBA for this. check digit equals what? I want the rightmost character off off the candidate, whatever's passed in. The right
One.
of candidate, one character. Okay, so I've now taken that rightmost character. So here's what we're doing with this algorithm. We're assuming that the last character is a check digit. If you've got a space after that check digit, or if you've got a hyphen or a dot, this is going to return invalid. We're assuming the last character is a check digit. We're putting it right there. Now, I want my first 9 to be everything but the last character. Might be more than 9 at this point. I'm okay with that. But I want everything but that last character. How do I do it? Someone help me here. First 9 equals what? The left of candidate. And I got to tell it how many characters. That's the hard part. How many characters? Yeah, however many there are. Length of candidate. But I don't want it all. I want -1.
Candidate.
Probably hard to see back there. Let me go ahead and darken that in for you. Thank you. Okay, so at this point, we can do a couple more checks. So at this point, what could we... In fact, let me do this. Instead of just taking the rightmost of this one, I'm going to uppercase that. Because remember... Oh, no, I haven't told you this. I don't think we've talked about this. Let's look at the algorithm. This book is an example. Let's look at the algorithm. The very last thing we're doing here is we are going to mod 11. So we're going to take the remainder of some number, divided by 11. We want to know what the remainder is. What's the possible outcomes from that step? It could be 0 through 10, right? If I take some number, divide it by 11, I say, this number, 11 goes to this number 18 times with a remainder of 11. What does that mean? No, I mean, it actually goes in 19 times with a remainder of 0. And so the result of mod 11 can only be 0 through 10. So the check digit can be 0 through 10. Now, we want our check digit to be one character. Is it possible to show 10 as one character? Well, yeah, if we're using base 11 or higher, that would do it. But we're going to be in base 10. Did I hear it? Did someone say another option? What? Roman numerals! Yeah! Oh! Roman numerals. Who knew that in 4th grade when you were learning Roman numerals, it would actually come in handy? Here it is. Now, you can use, what's Roman numeral for 10? X. And in fact, if you look, I know you can't see it. You can come look after class. The check digit on this book is an X. Because the result of the calculation described here is 10. And that's how you say 10 with one character. Has anyone worked in the book industry, like worked in the bookstore? Anyone here? They actually have keyboards. You know what I'm talking about?
I worked at the BYU item.
Oh, so maybe not so much. So they have some specialized keyboards for like just the book industry, and they actually have an X on the 10 key pad, so that you can type in ISBN numbers right on the 10 key pad. X over there. So the numlock, where the numlock is, there's an X. Okay. So what I'm going to do is, because I have to deal with the potential of that last character being an X, I don't want to have to worry uppercase or lowercase. When I first read it into my check digit, I'm going to make it uppercase. I'm just going to wrap a U case around that, so as it comes in, it'll be the uppercase version of it. So now I know my check digit's only one character, so I only peeled one character off. So at this point, I could do another check. I could say, hey, if my check digit's not numeric, or X, then get me out of here. I don't have to keep looking. We could do that. I'm going to skip that one for now. But I am going to look at first 9. At this point, I've now... Oh. I want to modify the first 9. At this point, first 9 is everything but the last character. What's the next step to first 9? Get everything that's not numeric out of it. So I'm going to set it equal to something else. First 9 equals, help me out, what am I going to say? Numbers only. I'm going to set it down first 9. So I've got spaces, I could have letters, whatever, in this thing. I'm going to take that value, send it down to numbers only. Numbers only going to do what it does, and it's going to send back just the numeric portion of it. Once that happens, I'm going to take a hard look at first 9. What could you tell me has to be true about first 9 if this is a valid ISBN at this point? It's got to be exactly 9 characters. If it's not, it can't be valid. Let's do that. If the length of first 9 is different from 9, then exit function. Not the right number of digits. Now, at this point, here's what we know. We know we've got one character over there unchecked. We know that we have exactly 9 characters to work with. That's great. Now we don't have to worry about looking at the 9th character when there's only 8. That would give us an error. If we made it this far, we've got 9 characters. Okay, so now we want to start doing the algorithm. The algorithm says, take the first character of those first 9, take the first character, multiply it by 10. Question?
So if you do exit function, does it just automatically return false?
So when I say exit function here, that says jump to the end of the function and get out of here. And so when we exit function, if we haven't told it to return true, we've never told it what to return, it will return the default value for its data type.
That's false.
That's false. Boolean's default is false. Yeah. Some people really like to see that, you know what, I know it's false, but let's start this thing off by setting it equal to false. And then I can see it in the code, but when I say it's the default, you should know it. Question?
Why don't you use and if by the end?
Oh! This is, yeah. So every time we've done an if statement, we've done an and if. This is a special function. This is the special form of the if statement. Typically, you don't put anything after the then. But if you only have one statement you want to execute conditionally, you can put it on the same line with the if statement. In which case, not only do you not have to put the end if, you can't put the end if. It's the one-line version. Folks, when BASIC was first written as a language, that's the only version you had. There was no else, there was no end if. You could only execute one statement conditionally. It was a nightmare.
You can change the first 9 date from number to 9.
If you want to have no variable. Thank you. Yeah, that's got to be the number. Incidentally, let me put that back. As a misspelled variable. Did we talk about option explicit? There are several options we can put up here at the top. These are compiler directives. What these say is to the compiler the compiler is the software that looks at what you've written and tries to figure out what you mean. I'm telling it, I'm giving that compiler a direction. I am telling it, when you look at this code, I want you to look at it this way. And option explicit says, I want you to require me to explicitly declare my variables. Turns out, without this, when the VBA interpreter looked at this, it would go, first 9, what the heck is first 9? Go, it's not function, it's not variable to declare. It's not part of the language. It's not some other function. I have no idea what this is. The only thing it can possibly be is a variable. But the programmer hasn't defined it. There's no dim for this. And the VBA interpreter goes, oh, you poor, sorry little programmer. You have forgotten to declare this variable. That's okay. I'll declare it for you. I'll make it a variant, and we can start using it. And so here, I'm thinking that I'm working with the actual first 9 characters, but it would say, no, it's just an empty length string. It's just a brand new variant variable. So without option explicit, it would just say, yeah, that's okay. But with option explicit, when I try to run this, it's going to say, not happening. Variable not defined. And that happens because I said option explicit. What this really is, this is a spell checker for your variable names. One of the hardest things to debug is a misspelled variable name. It really is. You look at it, you think you got it spelled right, you can't understand why it's not working. Okay, this question here, we'll go here.
So first 9 number, what? So it's defined twice right there.
Ah,
Or are those two different?
so here's what happens. Here's the first time I'm putting a value. At this point, when I declare this as a string, memory gets allocated, and it says, hey, there's nothing there. Now I get to this, and I'm going to say, I'm going to put something there. It's going to be everything but the last character of the candidate. And it said it takes those characters, puts them over there in the first 9.
Now you're taking part of that.
Yep. And now I'm going to say, I want to put something else there. It was nice while it lasted. It was there for a millisecond or less. And now I want to put something else there. What do I want it to be? I want it to be whatever this function returns when I pass first 9 down to it. Send that whole thing down. It's going to come back to something else, and I'll write over the top of it. I could have just taken numbers only and wrapped it around this part. Just numbers only with that in the middle. But I want to break it into a separate step just so we can kind of follow it through in smaller pieces. Question here.
How do you get option explicit to appear automatically?
If I want to make option explicit appear, hey, where's my? I thought I wrote variable name. Check spell check. The way you make it happen automatically, you come to Tools, Options, and right here, Require Variable Declaration. That doesn't really require variable declaration. It says when you make a module, put option explicit at the top. You can still delete it. If the module's already there, it won't put it there, but when it's created, it'll put it there. Got it? Got it. Okay. Okay. I forgot where we were. Let's see. We've done this. Get me out of here. Oh, we're ready. So at this point, we know that our first line has 9 digits. We know they're all numeric, and we're ready to start processing. So let's do the algorithm. I'm going to need somewhere to kind of store up all these values. I'm about to take that first number multiplied by 10, then I got to add it to the next number multiplied by 9, and so forth. I'm going to need some location in memory to store that as I'm adding that value up. I'm going to call it checksum, and I'm going to make it an integer. So I've declared checksum as an integer, and now I'm going to start writing these without a loop, and then we're going to build a loop. So here's what I want to do. I want checksum. The first part, I want checksum equal to 10 times what? What expression do I put here? The mid of first 9. Oh, I got to change this to 9. That's the whole point. That's where we went. 9. First 9, the mid of first 9, starting at the first character and taking 1 character. Then, after I do that, I want checksum to equal what it used to be, plus, starting at the 9th character, 9 times, starting at the 2nd character and taking 1. Then go to the 8 times the 3rd character. 7 times the 4th character. Now, I'm kind of seeing a pattern here, at least in these last 3. How could I modify that first line to make it look like it's following the same pattern? Checksum's going to start at 0, so if I had another checksum right here, that's okay. It'd be 0 plus, that's all right. 0 is the additive identity, it's not going to change the value of it. So now, I could just keep going. There's only 9 of them after all. I could just write them all in. But I want to do this with a loop. So I'm looking at these. There's only 2 differences in all these lines. What's the difference? This number here goes 10, 9, 8, 7, 6. And this number here goes 1, 2, 3, 4. So if I can write a loop, a for loop, that will have variables manipulating that, then I can just change all these 9 statements into 1 statement in a loop. Go ahead.
I just had a random question. So if you had a for loop and you knew you were only going to do 10, like we're going to do here probably, would it be more efficient to not use a for loop? Can't for loop sometimes slow stuff down?
Would a for loop slow something down? Oh, you mean just do it like this, just write it in?
Yeah.
Whew. if it slows something down, you're talking about sub-millisecond timing. It's not going to
If you have
slow.
like for loop, for loop, for loop, for loop. If you have a bunch of for loops within for loops, and you know you can get rid of a bunch of for loops by just doing the 10 lines each time.
Yeah, you might do that. You're talking about saving nanoseconds. Yeah, because you're saying, I can just execute this, then execute the next one, but the only difference is you've got a jump that happens in memory, and that happens way less than a millisecond to jump in memory. So yeah, that's not the way to optimize code. You better optimize it for readability and for maintainability. So let me go ahead and I'm going to declare a variable up here to control this loop, give x as an integer. Anything of the for loop right here, where x equals 1 to 9. I know it's going to be 9 characters. Put the next down here. All right. Now, I'm going to just bring one of these in here. And I'm going to think about, let's do this one first. This right here has to go 1, 2, 3, 4, 5, 6, 7, 8, 9. What expression do I put here? Yeah, x is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that with x. This has to go 10, 9, 8, 7, 6, 5, 4. What do I put here? If I put 10 minus x, x will be 1 the first time. The first time, that's going to be 9. So it should be 11 minus x. Put that in parentheses, make sure it happens first. 11 minus x. And so now, the first time through this loop, that's the line we're going to have. The second time through the loop, that's the line we're going to have. The third time through the loop, that's the line. This is what we're after. I've found, especially when you're brand new at writing loops, it's sometimes helpful to say, what are the statements I actually want to execute? Write a few of those, and then say, all right, what parts of this do I have to change? There's a question back here. Question? You good? Oh, it's a little thing. I'm going to just file that away. Sometimes ignore the question long enough, it goes away. That's good to do. All right. So at this point, I think it's probably a good idea for me to put a breakpoint right here and step through this code. We've got 5 minutes to finish this up. We're going to make it, folks.
You still in the U case?
Did I put the U case in? I put the U case here. So it's in case that check digit's an X, I just want to force it to an uppercase X so that I know what I've got. Uppercase 2 is still 2. Okay, let me go ahead and bring over the ISBN from here. I'm going to call this function ISBN-2. That's the one. All right, so now I'm going to call this function. It's going to break right before I get to here, but I want to watch what that checksum does as we're working through it. Okay, so right now checksum should be 0. I haven't actually done anything. Now we're going to iterate through this. Okay, so the first one, it should have taken, oh good, 0 times 10. It's still going to be 0. So we look at checksum now, it's still 0. I'm going to execute this again. Checksum now should be 3 times 9. Should be 27. There it is. Execute again. Now it should be 27 plus 0 times 3. Still 27. So did I execute it right? I can't remember if I did that one or not. Here's the next one. Okay, so now we've added on 6 times 4. We'll continue to add those on. Is that the numbers we're expecting to get? 6 times 7, thank you. If we look here, yeah, 0, 27, 0, 42. Yeah, that's the stream of numbers we're after. Put a breakpoint here, and I'll run it the rest of the way. And let's take a look at checksum now. It's 130. That's it. Okay, so we've done this long part, and now we just have to take that mod 11. That's the next step. I don't need 130 around here for anything else, and so I'm going to build that right here in checksum. Checksum equals checksum mod 11. I'll execute that line. Checksum is now 9. Is that what I expected to be? Yeah. So now we're looking at this part here. Now we should have 11 minus 9. Take that whole thing, mod 11. I'll do those in 2 separate steps. Checksum equals checksum minus 9. And then checksum equals checksum mod 11. Is that right? Subtract the 9 first. No, it's 11 minus 9. I want, this should be 11. This should be 11 minus our checksum. Thank you. 11 minus the checksum. And then it should be that number mod 11. That should be right. So we're going to execute that. Take a look at our checksum. Checksum's now 2. We've calculated down to the value that we're after. Now all we have to do is check to see if that value is the right check digit. So we're going to say, listen, if the checksum equals the check digit, we're good. There's one other condition. What else could we have? There's one other way this could be true. The checksum equals the check digit, or the checksum is 10 and the check digit is X. So we're going to put here an or, put this in parentheses, or the checksum equals 10 and check digit equals X. If that's the case, then we want to set is valid. Copy that. Is valid ISBN equals true. That's the only thing that can give us the true. Checksum is equal to check digit, or the checksum is 10 and the check digit is X. At this point, anything else is going to return false. And so if we haven't returned true, it'll return false. I'm going to run it now here. Get rid of this breakpoint. And that's true. I change any one of these numbers, it'll return false. Change it back. If I transpose them, believe me, if I transpose them, it's going to go false too. Let me go ahead and put this into Excel just so you can see it in the worksheet. Here's a check digit. I'm going to say that, or that's the ISBN. This equals is valid ISBN 10. Look at that. That one's true. We'll put it here. Value.
Capital.
I'm handling the capital. I think that apostrophe comes into it. Right. That's a good question. Do I have it? Maybe I just typed it in wrong. No, it should return true or false. Pity. We are at the end of time. At least put this one here and change this to a different check digit. That one should return false. I'm not sure I've done wrong here, or why it's. I'll have to debug that. No, that's not. Apostrophe's gone. Pretty sure that's not the apostrophe. I'll have to debug that. I'll try to update the video and let you go on. All right, that's going to be it for today.
Can you go back to your code real quick?
Back to the code. Questions? Class dismissed. That should still be okay. The code should have. All right, so I'm going to step That's 3 that it's Oh, here's the problem, folks, if you want to take a look at it. This value right here is checking to see if the number is equal to the x. And this is the expression that it doesn't like. So my solution on this is going to be this. I'm going to check this one first. If that is, return true. Else if, we'll talk about this version of the if statement. Else if that one, then the problem is this check is failing when it's an x. So if it's an x, I want to go through this and I'm done. Otherwise, it's not an x, I'll be able to run through this. And that should let me know that's valid. Because when this is an x, this check fails. All right, thanks for coming. See you next week.